Okay, so now that we've proven the first property of vector addition, we're going to prove the other three. So let's start off with u plus 0 is equal to u. To do this, we're going to have to be using, I know. Okay, so let's say we have the triangle A, B, and C. Then by the triangle rule, we've derived that AC is u plus. It represents the free vector u plus v. If I was to write this out as ABC, the triangle, and I told you AB represents u and BC represents v, then AC represents u plus v. So then if we did this with I'm not sure if that was very clear, but if we did it with a degenerate triangle, a triangle where two of the sides are the same, and we say AB represents u, BB represents 0, then the whole triangle represents AB, which is u by the triangle rule, so u plus 0 is equal to u. Now we're going to use that again to prove u plus minus u is equal to 0. And remember, minus u is just the free vector with the same length as u, but in the opposite direction. So let's do this exercise again. So A, B, A this time. AB represents u, BA represents minus u, and all of this is equal to AA, which is 0. So by the triangle rule again, u plus minus u is equal to 0. Now onto the last one, which is u plus v plus w is equal to u plus v plus w. Now we are going to write that as u, that is v, and then we have our w, so A, B, C, and D. Now if I was to use the triangle rule on BD, I would see that this equals to, using the triangle BCD, this equals to V plus W. Now if I now take the triangle ABD, ABD, this is V plus W, and this is U. So by the triangle rule, AD represents the free vector U plus V plus W. Now if I do this again on AC, with the triangle ABC, then I have U plus V. And then if I take the triangle ACD, equals W. Then by the triangle rule, AD represents U plus V plus W. And since AD represents this free vector and AD represents this free vector, then they must be equal. So U plus V plus W is equal to U plus V